Back in section 2.1, we talked about computing average velocity. We said average velocity is the change in distance divided by the change in time. And then we said if we wanted to find instantaneous velocity, we could use that same formula, change in distance over change in time. We're just going to let the two time values get so close together that essentially there's no time between them. So see what we have here. I have a graph here. This is a distance function, and I want to find average velocity. So I'm going to find f of b minus f of a over b minus a, or change in distance over change in time. If I wanted to find instantaneous velocity, I would let those 2 points get closer and closer together. So notice what happens here. The change in distance over the change in time. So average velocity, if I take the limit as those 2 points get closer and closer together, I'm getting instantaneous velocity, which we now also know if I let those 2 points get closer and closer together, I'm finding the slope of the tangent line. So instantaneous velocity is the same as the slope of the distance function. That tells us that velocity is the derivative of the distance function or the position function. So that's your first fact there. Velocity is the first derivative of position. Pretty commonly we use s of t. S is the function name, t is the input, so s is a function of time for distance. So we wouldn't usually use d for distance, we usually use s for distance. And then velocity is the derivative of the position function. So there's 2 different notations. We could say v of t is equal to s prime of t, or equivalently, v of t is the same as ds dt, so the derivative of position with respect to time. Okay, and then there's a problem there on your paper. So here's the function we're given. We've been told s of t, the distance function, is t squared minus 5t plus 1. We've been asked to write an expression for the velocity of the car. So the velocity of the car, which is v of t, that's v of t, is the derivative of s, so that's equal to s prime of t. And I know how to take the derivative of a polynomial. The derivative of t squared is 2t. I'm using the sum and difference rule. I have a subtraction sign. And the derivative of 5t is 5. So v of t is equal to s prime of t, and that's 2t minus 5. I have a second important fact, and speed, just by definition, speed is equal to the absolute value of velocity. So we had a question here in the example above, what is the speed of the car at time t equals 2? Well, we knew that. V of t, we said, was equal to 2t minus 5. We've been asked what the time is, what the speed is at time 2. So v of 2, first I need to find the velocity at time 2. And that's equal to, I'm plugging 2 in for t into the v function, 2 times 2 minus 5, which is -1. So the speed at time 2 is equal to the absolute value of v of 2, which is equal to the absolute value of -1, which is equal to +1 is the answer there. Now, 2 important velocity facts. You'll hear this on the AP test. So a body is at rest. Anything that's floating through the air, a body, something that's moving through time or space, is at rest if its velocity is 0. So this is an actual released multiple choice question from 1988, number 16, says a particle moves along the x-axis so that its position is given by the function x of t is t cubed minus 3t squared minus 9t plus 1. And for what values of t is the particle at rest? So the particle is at rest when the velocity is 0. So I'm going to find the velocity first and then set that equal to 0. So v of t is the derivative of x, derivative of position, so v of t is equal to x prime of t, which is equal to, the 3 comes down, this is going to be 3t squared, minus 2 times 3 is 6t, minus 9. Okay, so my first step was to find the velocity. V of t is 3t squared minus 6t minus 9. I'm going to take that velocity and set it equal to 0. So I'm going to write 3t squared minus 6t minus 9 equals 0. And now all I have to do is solve this equation. So I'm going to divide everything by 3. I get t squared minus 2t minus 3 equals 0. I'm going to have to factor this as t minus 3 times t plus 1 equals 0. And for me, that has two solutions. So my solutions are time equals 3 and time equals -1. My only thing left to do is to notice that the function I started with, the position function, is only defined when time is 0 or greater. So I'm going to take this answer that I got, t equals -1, and I'm going to cross it out. So my final answer here, the particle is at rest at time t equals 3.